This week we're going to be learning about earth processes of weathering and erosion. And in order to understand better weathering and erosion, I thought we should start with the rock cycle. So our reading for today is going to be a ReadWorks article on the rock cycle. Now, whenever we start, I like to preview the text, so SQ3R, survey, question, read, recite, review. And I'm going to survey quickly, and we see that we have one heading here and a couple of paragraphs. And then when I move on to the next page, I have a nice little diagram that is going to explain some of the information better on the second page. And the third, and I see I have some keywords here. So I have igneous rock, magma, volcanic eruption. And then I have a really nice chart or display rather that has some arrows that's going to show us an overall process. Here another picture and some more paragraphs. So I've surveyed my text. I'm kind of interested in it. On this one right here, I get some words that I've never seen before. So I see this word igneous rock, I see sedimentary rock, and I see metamorphic rock. So I know I'm going to be learning about three main types of rocks in this rock cycle. Now I'm going to go ahead and question, and I'm going to write, well, what is the rock cycle? And after reading this article, I need to make notes that can answer that overall question. What is the rock cycle? So let's begin reading. Rocks you see in the world around you might seem like permanent fixtures. And let's recall that that word permanent means always there or fixed. So fixed or always there. Given enough time, however, all rocks change. That's important. They are created, destroyed, and recreated in a continuous cycle. So there's a cycle. A continuous means always occurring. A continuous cycle where rocks are created, destroyed, and recreated. Geologists call this ongoing process, which is another word for continuous. So I'm going to do ongoing and continuous is the same. Geologists call this ongoing process the rock cycle. So I'm going to make a note at the bottom of my page so that I can remember, and it kind of answers this question, what is the rock cycle? And I'm going to write that the rock cycle is, and I'm going to go back up to what I've underlined, well, it's a continuous cycle where rocks are created, destroyed, and recreated. Right there, so as I'm done with this and we've surveyed, I've created a question, we're reading, and this will be part of the reciting. So I'm going to recite, as I'm trying to study and remember this information, I'm going to recite this in my studying, and then I can go back to it a little later and review the notes that I've made and the things that I've underlined. So that's part of the SQ3R process. So paragraph 2, the rock cycle has no starting or ending point. You can jump in anywhere to see how it works. Let's begin with magma erupting from a towering volcano. The magma, now lava, cools and hardens into igneous rock. So right here we know what kind of rock igneous is. Igneous rock is cooled magma or lava. It's cooled lava. Over the course of thousands of years, sun, wind, rain, and freezing temperatures cause the rock to weather or break down into smaller pieces. This is going to be one of those important science words we're going to be talking about over the next couple days, weathering. So we know that weathering is the breaking down of rock into smaller pieces. And the things that cause weathering are going to be the sun, wind, rain, and freezing temperatures. The pieces continue to weather, slowly breaking down into sediments. This is going to be another key science word. So sediment is going to be those smaller particles that have been broken down. howling winds, which is going to be really fierce winds, flowing water, and gravity gradually move the sediments down the sides of the volcano and beyond. Movement of sediments from place to place is called erosion. So here's another key term for us, erosion, and that is the movement of sediments from place to place. So I'm going to make some notes based on what we have right here. So the first one we came to that I underlined, and let me put a box around those key science words that we're looking at, igneous rock. An igneous rock, if you recall, is cooled lava rock. And the other word that we put a box around is weather. And we know that weathering is breaking down rocks into smaller pieces. And that happens from, over time, right? So weathering is breaking down a rock into smaller pieces over time from sun, wind, rain, and freezing temperatures. And the next word we put a box around is sediments. So the pieces continue to weather, slowly breaking down into sediments. So I'm going to put that sediments is broken down rock. Or rather, sediments are broken down rock. And then lastly, we have this word erosion boxed, and we know that wind, flowing water, and gravity move the sediment down the sides of the volcano and beyond. And the movement of sediment from place to place is called erosion. So we're going to write our final note here. Erosion is the movement of sediment by or from wind, water, and gravity. And you can always pause the video if you need to in order to make these notes yourself, but I'm going to continue on. Okay, so what this graph right here, this picture rather, is showing us is that it's the igneous rock is created as magma comes up through a volcano and spews over, igneous rock is made. So when we think of volcano, we should think of igneous rock. Volcanoes create, O-E-S, sorry about that, create igneous rock. V-O-L-C-A-N-O-E-S, create igneous rock. And moving on to this page, the first paragraph, imagine that the sediments, which is that broken up rock particles, end up in a lake where they settle down to the bottom. Over long periods of time, more layers of sediments are deposited on top of them. So this is an important word here, deposit. Which means to just be put somewhere, if you will. So it's deposited, it's taken somewhere. So compacting and cementing processes eventually turn deeply buried sediments into sedimentary rock. So sedimentary rock is compacted and cemented sediments, essentially. Compacted and cemented sediments. And I'm going to write that down here at the bottom. Sedimentary rock is compacted and cemented sediments. So now imagine that the sedimentary rock is near the edge of a tectonic plate. The plate collides with another plate very slowly, of course. Tremendous heat and pressure generated by the collision gradually turn the sedimentary rock into metamorphic rock. So heat and pressure convert sedimentary rock into metamorphic rock. As the plates continue colliding, their rocky edges crumble. The metamorphic rock is slowly pushed up higher onto the Earth's surface. Think of mountains. Exposed to air, rain, and snow, the rock begins to weather and erode. So metamorphic rock can also be pushed up to the Earth's surface when plates collide and build mountains, and those can also be eroded over time. So I'm going to make my note, because I'm running out of space, of metamorphic rock up here. So metamorphic rock is sedimentary rock that has undergone extreme heat and pressure. Now I have a rock here that I kind of wanted to show you all, and this is a rock that we took from Lake Millerton, and this appears to be a sedimentary rock. However, it has some crystals in it, so I believe this rock to have been a sedimentary rock that actually underwent extreme heat and pressure, therefore making it more of metamorphic in nature because it has developed some crystals over time. So what we can tell, the reason we can tell it was once sedimentary is because it has these really nice layers of different rock, and we can tell that based on the color. And then we know it's undergone extreme heat and pressure because we can see crystalline structures here in the rock, especially right here. You can see what appears to be like some quartz, and this would be how maybe over time we would get granite as well, beautiful grains. That's going to be that heavily pressed metamorphic rock. So this is once sedimentary, and it appears now to be metamorphic as it has come on land. Now if this were to continue to stay outside and weather, it would break down further and become a new layer of sedimentary rock, and then that sedimentary rock under extreme heat and pressure would then form metamorphic rock. So moving on in our reading, we're on our final page, and we're going to start reading before we look at our picture here. Well, we can look at the picture. So what we see is we have a mountain. So we're imagining that this mountain is either igneous rock from a lava flow, or it could be pushed up metamorphic rock. And over time, we're going to have weathering occur, which is going to happen from the sun, from rain, from freezing temperatures. And remember, weathering is actually the breaking down of rock. We want to think of weather breaks. And then erosion is simply the movement of those broken down rocks into a lower area or movement somewhere else. So gravity helps pull rocks into lower areas where they are deposited over one another in layers. And then we have a compaction and cementation process. And as layer upon layer begins to build, this sedimentary rock begins to be pushed closer and closer down, and you can see how the boundary between sedimentary and metamorphic rock, they really pretty much abut each other, because it is going to be that extreme heat and pressure that's going to convert that sedimentary rock into metamorphic rock. and we're going to go ahead and finish reading. Alternatively, one tectonic plate might be sliding beneath another. The metamorphic rock along the edge of the descending plate gets hotter and hotter as it nears the mantle. At some point, it melts into magma that someday might erupt from a volcano again as lava. So understanding how rocks change helps geologists understand how Earth has changed over time. So there's a process where the metamorphic rock can be raised as a mountain, right? It can be pushed up with two plates collide, or if two plates collide and one plate goes down, this plate carrying the metamorphic rock would then be melted back into magma. And that's kind of what this picture right here shows you. So igneous rock, if it's weathered, it becomes sediments, and it becomes compacted into sedimentary rock, which then under heat and pressure becomes metamorphic rock. Metamorphic rock can be converted to magma if it's pushed down. And then we can also go the opposite way, so with the rock cycle as well.